Start.
Warm greetings to very dear judges. We of MD Affairs presenting you the autonomous self-driving car. An autonomous self-driving car is basically a robotic vehicle that travels between distances without human intervention. The execution of a self-driving car model is done using a basic algorithm that involves the following steps. That is lane detection, grayscaling, Gaussian blur, canny edge detection, and computation of region of interest and hue space. Lane detection basically involves a self-driving car capturing 20 frames per second using its camera from which the longest lines are being determined. After the longest lines are being determined, the lane detection process is complete. Once the lane detection process is complete, we shift on to grayscaling. The image that is captured in the first phase is converted into a grayscale image to find all the obstructions and disturbances. Once the grayscaling is complete, the Gaussian blur effect is done. The Gaussian blur function is used to blur the lines and find the longest lines without any divisions between the lines. This helps us to find the canny edge detection. The canny edge detection is used to find the edges between which the car has to drive, leaving out all the obstacles in between. Once the canny edge detection is done, we move on to computation of region of interest. The region of interest, as the name specifies, gives the region in which the car has to move. Once the canny edge detection is done, the ROI algorithm is implemented to find the region of interest, the lines between which the car has to drive. Once the region of interest is found, the hue space is found out. The hue space gives two determinant lines between which the car has to travel. This also specifies the directions in which the car has to travel. The slope of these two lines are found out to determine whether the car has to move straight, left, or right. If the slope is positive, the car moves towards the right. If the slope is negative, the car moves towards the left. Else, the car moves straight. So, this is the execution phase of our autonomous car. And coming to the SWOT analysis, exactly a SWOT analysis has been carried out for this product. The given below are the strengths. Strengths being safer transportation, transport for the impaired, less stressful driving experience, provides time for other activities. These are the strengths. And coming to the weaknesses, we have weaknesses like reliance on technology, lack of data, much testing is required as of now, and unclear legal implications. And the given below are a few opportunities that are available for the self-driving autonomous cars. And here are a few threats that can be resolved using further future implementations. Elimination of existing jobs, privacy concerns, injury due to fatal design, and misuse of technology are a few threats available for these cars. And later, we coming to the requirements, we use Python to implement this algorithm. The basic code has been written in Python, and OpenCV is used for lane detection, Gaussian blur, and a camera is used for the real-world implication of an autonomous car. Machine learning is used here. The neural network used is Alex network for object detection and various other facilities that machine learning provides to make it a better autonomous car and also increase its efficiency. This is by women and for women. With our agent, we aim to address the issue of women's safety, which is a major concern in the modern society. There are a lot of security issues when women travel in cabs or with drivers. To avoid this, we implement self-driving cars wherein women can travel safer, avoiding accidents and avoiding any other kinds of dangers. So this is one of the basic advantage and a boon for women. Future enhancements. Implications of face detection within the car help take control over the car when required. For example, when a person is feeling sleepy or when he is drunk, or many more examples like this can be taken to recognize the face and also take control over the car depending upon the driver's mood. maintain a network of all autonomous cars to provide a better prediction by referring to the information shared by all the cars in this network. During the sale of the autonomous car, it can be connected into a network, and everything that this car records and reads and learns can be implemented into the network such that all the other cars in the same network can get more information and help drive better with making future enhancements. Designing the autonomous car in such a way that can be spontaneously make for future decisions to navigate safely and comfortably through everyday traffic. Making future decisions like getting to know when a vehicle is coming forward and making future predictions like that would help the car to drive more efficiently. This is one of the basic future enhancement that we would like to implement to this car. And now, this is coming to our team, FEMD Affairs. We are three of us presenting to you this beautiful model, a self-driving autonomous car. We thank you for providing this platform for us to develop something useful and nice for the society, especially for women. Thank you all.